Hello dear friends, welcome back to online video lecture series of Jet Propulsion and Aircraft Engineering. This is lecture 9 for the fundamental of gas dynamics. In this video lecture, we are also going to continue the numerical which we have started in previous couple of video session. So we are going to solve a numerical 3 in this video session. So let's start the example. An aircraft is flying at an altitude of 11,000 meter at 800 kilometer per hour. The air is reversibly compressed in an inlet diffuser. The inlet temperature is 216.65 Kelvin and the pressure is 0.226 bar. The Mach number at the exit of the diffuser is 0.35. Also gamma 1.4 and characteristics gas constant R, which is 287 joule per kilogram Kelvin. So for there we are going to take gamma as a 1.4 and R as a 287 joule per kilogram Kelvin. So these are the data which is given to us. On the basis of the data, we need to calculate. The first thing is entry Mach number, means the Mach number at section 1, M1. Second thing, velocity, pressure and temperature of air at the diffuser exit, means we need to calculate the velocity, pressure and temperature at section 2, means V2, P2 and T2. So these are the different findings that we need to calculate in these numericals. So let's start the solution. First of all, we need to go through the given data. So first thing is that Z, which is equal to 11,000 meter, Mach number at entry which is M2 0.35, then P1 pressure at section 1 0.226 bar, T1 at section 1 216.65 Kelvin, C1 which is given to us 800 km per hour, and I am going to convert that into the meter per second, so that would be 222.2 meter per second. Then after gamma 1.4 and R 287 joule per kilogram Kelvin. So these are the data which would given which has given to us, and on the basis of that we need to calculate M1, C2, P2 and T2, Mach number at entry, then velocity, pressure and temperature at exit at section 2. So let's solve the example. First thing is that velocity of sound. Now we know the formula for velocity of sound, A, which is equal to under root of gamma R T. So since we are calculating it for the section 1, I am going to write A1 is equal to under root of gamma R T1. Let's put the values here. Therefore A1 is equal to under root of 1.4 into 287 into 216.65, which is the temperature at the inlet. So after going through the calculations, I would get A1 is equal to 295.04 meter per second, which is the velocity of sound. Now it's time to calculate the Mach number at section 1, M1. Since we have both the values C1 and A1, I should be able to calculate the Mach number at the entry. So therefore we know that M is a ratio of object velocity to the sound velocity. So I should be able to write down M1 is equal to C1 divided by A1. So therefore let's put the values. M1 is equal to 222.22, which is C1, and A1 that we have calculated in previous slide, that is 295.04. So now after going through the calculations, I'll get M1 is equal to 0.753, which is the Mach number at the entry or the at section 1. So this is our first finding. Now let's move forward to our next finding. Our next thing is we need to calculate the pressure, temperature and the velocity at section 2 at exit. So for that we are going to need different conditions. We are going to need stagnation temperature and pressure. So first things that we need to calculate here is a stagnation temperature and stagnation pressure. Now how would you get the ratio from the temperature at section 1 to TO, or pressure from section 1 to PO? That can be taken, or that can be referred from the gas table. Now gas table is available with the many books. Here we need to use the gas table to calculate the ratio. and on the basis of that you will find you will get certain values, and once you have like at least one unknown, you can calculate the rest of the parameters. So here I'm going to use the gas table, and you will see the couple of data which I've got from the gas table. But to get these value, we need to have a couple of references. So here I'm going to use gamma and Mach number at section 1 as a reference. So I've got gamma which is 1.4 and Mach number at section 1 which is 0.75. So these two references can be used to find out the ratio for the both temperature and pressure. So from gas table, I'll got the ratio from T1 to TO which is equal to 0.899, and the ratio of pressure P1 to PO which is equal to 0.688. Now I'm going to use this ratio to calculate both TO and PO. So let's start. Now since we got this value, we know T1 upon TO is equal to 0.899 and I have the T1. So on the basis of that, I should be able to get TO. So therefore, TO is equal to T1 upon 0.899. I'm going to put the values of T1 which is 216.65 divided by 0.899, and I'll get the TO which is equal to 240.98 Kelvin. So this is the stagnation temperature. Furthermore, it has been given that the flow is isentropic, and for isentropic flow the stagnation's temperature would remain constant, and therefore I should be able to write down TO which is equal to TO1 which is equal to TO2. Since we got TO already, I'll get TO which is equal to TO1 which is equal to TO2, and that is 240.98 Kelvin. Okay. Now let's calculate the pressure at stagnation conditions. P1 upon PO which is equal to 0.688 which we have taken from the gas table, and I have the values of P1 which is at the inlet. So I'm going to find the PO now. Let's say 0.226 divided by PO which is equal to 0.688, and therefore PO is equal to 0.328 bar. Okay, so this is the pressure at stagnation condition. Furthermore, since it is isentropic flow, the pressure stagnation pressure is also remain constant, and therefore PO which is equal to PO1 which is equal to PO2, and that would be 0.328 bar. So here we have the stagnation pressure constant for the throughout sections. Alright. Now for exit, on the same way we are going to calculate the ratio at exit 2. So let's say T2 upon TO2 which is equal to 0.976 and P2 upon PO2 which is equal to 0.918. Now this data has also been taken from the gas table at different conditions, at different references. Here I am going to use gamma as well as Mach number, but that is at section 2. Since gamma is constant, but the Mach number would change here. So we know that gamma is equal to 1.4 and the Mach number which is equal to 0.35. I'm going to refer these two references and find out the values of the ratio of temperature and pressure from the gas table, and therefore T2 and T2 upon TO2 that would be 0.976 and P2 upon PO2 that is 0.918 which we have taken from the gas table. Now since we know that T2 upon TO2 is equal to 0.976 and we have the values of TO2 as well which we have calculated earlier, I should be able to get the temperature at section 2 or temperature at exit. So T2 which is equal to 0.976 into TO2. I'm going to put the values of TO2, so that would be 0.976 into 240.98, and after going through the calculation I'll get T2 is equal to 235.19 Kelvin. So that is the temperature at section 2. This is our second finding. Okay, now let's move forward to calculate the pressure at exit or pressure at section 2. We are going to use the same ratio which we have taken from the gas table. So let's say the ratio says P2 upon PO2, which is equal to 0.918, and we have the values of pressure at stagnation pressure at section 2 as well. So let's write down P2 is equal to 0.918 into PO2, and therefore that would be 0.918 into 0.328, and therefore the P2 would be 0.301 bar. So this is our third finding which we have find out. Now let's move forward to the last one. Here in last section we need to calculate the velocity at section 2, and we are going to use the Mach number equation. Mach number, which is the object velocity to the sound velocity. Since we have the Mach number at section 2, but we have to calculate the velocity of sound at section 2 at exit, and for that we are going to use the equations called A is equal to under root of gamma r t, and it is for the section 2, that would be A2 is equal to under root of gamma r t2. We have all the values, we have gamma r and t2, so therefore I'm going to put those value in here, and that for I should be able to write down A2 is equal to under root of 1.4 into 287 into 235.19, and therefore A2 would be 307.41 meter per second. Then after I should be able to calculate the velocity at section 2, and for that I'm going to use the equation for exit Mach number, m, which is equal to c upon a, and since it is for the section 2, I'll write down m2 is equal to c2 upon a2. Now let's put the values here and calculate the velocity at section 2. So that equations can be rewrite as c2 is equal to m2 into a2. We have m2 0.35, we have a2 we just calculated in previous slide 307.41. So I'm going to put these values and calculate the velocity, and here the velocity would be 107.59 meter per second. So this is our last finding, which is the exit velocity at the section 2, and that is C2. So this is all we need to calculate all those 4 different findings to get the 7 marks in exam. This kind of numericals normally asked in GTU exam. This is all at the moment. If you have any doubt, you can write down in the comment box. Thank you very much.